Now what I'm going to look at is making functions differentiable, and this is going to look fairly similar to what we did in Unit 1, where I gave you a piecewise function and asked you to find specific values of a and b so that that function was continuous everywhere. Now, in this example, we're looking at this piecewise function, f of x equals 2ax squared minus x greater than 3, x cubed plus bx when x is less than or equal to 3. I want to figure out the a and b values so that this function is differentiable everywhere, so that it's continuous and so that it's smooth, no sharp turns, no vertical tangents. Take a moment, just copy that down. Before I start setting up some limits and all that stuff, let's take a moment and just calculate f prime of x, calculate our derivative. 2ax squared. What would the derivative of 2ax squared be? A is a constant, so I'm going to get 2a times 2. I'm just going to get 4x over there. No, I'm not. Let me try that again. I'm going to get 4ax over there. What's the derivative of minus x? Minus 1, when x is greater than 3. What's the derivative of the bottom piece? Derivative of x cubed is 3x squared, plus derivative of b times x is b times derivative of x is just 1. So we're going to get that. And remember, just don't put an equal sign on one of the pieces. Well, now, I need to, first of all, make f of x continuous. Which means that I need to say the limit as x approaches 3 from the left of f of x equals f of 3 equals the limit as x approaches 3 from the right of f of x. Take a moment and go make that equation. Okay, well, both of these are defined by the bottom part. I'm going to plug in a 3 where the x is. I'm going to get that. The other one is 2 times a times 3 squared minus 3. 27 plus 3b equals 9 times 2, 18a. No, that's not right. Yeah, that is right, sorry. 18a minus 3. That will work, or you can move the a's and b's to the same side, get 18a minus 3b equals 30. You can divide everything by 3 if you want, whatever. I'm just going to kind of leave it like this. The next thing we have to do is we have to make f prime of x continuous. So I'm going to go say the limit as x approaches 3 from the left of f prime of x equals the limit as x approaches 3 from the right of f prime of x. See if you can go deal with that and make an equation there. Okay, this is 3 times 3 squared plus b equals 4a times 3 minus 1. I'm getting 27 plus b equals 12a minus 1. Again, I might as well move some things around. And I'm going to say 12a minus b equals... This isn't right. Hold on. No, I guess it is right again. Equals 28. Now, you need to take a moment and solve that system of equations. Go try it. Go multiply the bottom by negative 3. That's going to give me 18a minus 3b equals 30. Minus 36a plus 3b equals, I don't know off the top of my head, I'm going on my calculator, negative 84. Negative 18a is going to equal negative 54. A A is going to be 3. 12 times 3 minus b equals 28. 36 minus b equals 28. Go solve that. B is going to equal 8. Go test this thing out. Click on the link that's going to come up. It'll take you to a Desmos window. Mess with the sliders and see if when A is 3 and B is 8, that thing looks differentiable, continuous, and smooth. No sharp turns, no vertical tangents. Let's try one more. Let's see here. Find M and B. So f of x, which is 1 plus 3bx plus 2x squared, when x is less than or equal to 1, and mx plus b, when x is greater than 1, is differentiable everywhere. After you've copied that down, take a few moments and go make it continuous equation. Actually, I take that back. Find your derivative. Once you've found the derivative, then make it continuous equation. So I told you to make f of x continuous. I'm going to say the limit, and make sure you are starting these with limits. I do need to see those. Limit as x approaches 1 from the left of f of x has to equal f of 1 has to equal the limit as x approaches 1 from the right of f of x. These are both defined by the top, so 1 plus 3b times 1 plus 2 times 1 squared equals, let's see, m times 1 plus b. 1 plus 3b plus 2 equals m plus b. You're going to get 3 plus 3b equals m plus b. Maybe I'll move things around and say m minus 2b equals 3 or something like that. Whatever. Take a moment, go make f prime of x continuous. Set up your two-part equation. Make your equation. Okay, so this is going to be 3b plus 4 times 1 equals m. 3b plus 4 equals m. Should be your equation. Go solve that system and let's get m and b. I might as well use substitution here and plug this thing in for the m over there. So I'm going to get 3 equals 3b plus 4 minus 2b. 3 equals b plus 4. B looks like negative 1. M is going to be 3 times negative 1 plus 4. That's positive 1. Go check that in Desmos. Like I said in Chapter 1 with the make it continuous type problems where we had to find the a and b that made the piecewise function continuous, this is also a pretty standard type of question on the AP exam. If for some reason they don't give you a here's a piecewise function, make it continuous problem, they will definitely give you a here's a piecewise function, make it differentiable type of problem.